Building end-to-end ML pipelines with TFX. Building end-to-end machine learning ML pipelines with TensorFlow Extended involves orchestrating various components and stages of the ML workflow, from data ingestion and pre-processing to model training, evaluation, and deployment. TFX provides a comprehensive set of tools and libraries for building, validating, and deploying production ML pipelines efficiently. Let's dive deeper into the key steps and components involved in building end-to-end ML pipelines with TFX. The first step out of 7 steps that are there is define the ML pipeline. The first step in building an end-to-end ML pipeline with TFX is to define the pipeline structure and stages. This includes specifying the sequence of components and tasks to be executed, as well as the data sources, input features, and output targets. Next, data ingestion and pre-processing. TFX provides components for ingesting and pre-processing trained data, including ExampleGen for ingesting data from various sources, example CSV files, BigQuery tables, and transform for performing feature engineering and data pre-processing using TensorFlow Transform. Third step, data validation and schema inference. TFX includes components for data validation and schema inference, such as StatisticsGen for computing descriptive statistics from training data, SchemaGen for inferring a schema from training data, and ExampleValidator for detecting anomalies and inconsistencies in training data based on the inferred schema. Fourth, model training and evaluation. TFX provides components for model training and evaluation, including trainer for training machine learning models using TensorFlow and evaluator for evaluating trained models and computing evaluation metrics. Developers can define custom model architecture and training configurations using TensorFlow's API. Fifth, model deployment. Once a model has been trained and evaluated, TFX includes components for deploying the model to production serving infrastructure, such as Pusher for deploying trained model to TensorFlow serving or other serving platforms. Developers can specify deployment configurations and integration points with serving infrastructure. Monitoring and governance. TFX includes tools for monitoring and governance, allowing developers to track pipeline execution, monitor model performance, and ensure compliance with regulatory requirements. This includes features such as model versioning, lineage tracking, and model monitoring. Seventh, orchestration and execution. TFX pipelines can be orchestrated and executed using various orchestration platforms, including Apache Airflow, Apache Beam, and Kubeflow pipelines. These frameworks manage the execution of pipeline components, handle dependencies between tasks, and provide visibilities into pipeline execution. Building end-to-end ML pipelines with TensorFlow Extended involves orchestrating various components and stages of the ML workflow, from data ingestion and pre-processing to model training, evaluation, and deployment. By leveraging TFX's comprehensive set of tools and libraries, developers can create robust and scalable ML pipelines that handle large-scale datasets, complex feature engineering tasks, and distributed training scenarios. Understanding the key steps and components involved in building end-to-end ML pipelines with TFX is essential for effectively deploying and managing ML workflows in production environments and realizing the full potential of machine learning for real-world applications.